This is how to find the mass moment of inertia of a yoga ball on top of a cart. The objects for this video were used from Just Common Household Objects by Alan Bungling. So if a student wants to find the mass moment of inertia of a yoga ball balanced on a cart, assuming that the center of gravity is the center of the yoga ball, the cart weighs 16 pounds while neglecting the bar's handles and wheels, and the yoga ball weighs 150 pounds with a diameter of 25.6 inches / 65 centimeters. What is the mass moment of the combined system? Now the parameters we take are that we're going to treat the cart as a thin plate, and we'd measure the length of the cart as 28.5 inches roughly. Using the tape measure, we get 28.5, and then measuring the width of the cart, we get about 19 inches. And the yoga ball, because my height would be 5'5", we're just basing this on relative dimensions. So the yoga ball would be around 25.6 inches when it comes to the diameter, of the yoga ball. Now the theory for this would, to find the mass moment of inertia would be figuring out where the center of gravity is, and the formulas for sphere and thin plate, which would be 2/5 times the mass radius squared, 1/12 of the times the mass, length squared plus width squared. We're treating the yoga ball as the sphere, and we're treating the cart tray as the thin plate. And then, as we said before, weight of the cart 16 pounds, weight of the yoga ball 150 pounds, diameter of the yoga ball 25.6 inches, but we'd have to divide that by 2 to find the radius. Length of the cart 28.5 inches, width of the cart 19 inches. We're going to assume that gravity is acting on the system, but it is a rigid body in place, and the center of gravity, like we said, is center of the yoga ball. And the drawing, this is the yoga ball on top of the cart. Its height from the center of the yoga ball, which would be the radius, and the width from the center of the yoga ball would also be its radius, since all points around a sphere are equidistant of its center. The cart's dimensions from the earlier parameters, 28.5 inches in length and 19 inches in width. And to find the solution, we would convert the weight of the yoga ball and the cart to kilograms to have consistent units. Divide the diameter in half to find the radius, and utilize the mass moment of inertia formulas to find the mass moment of inertia about both objects. We come out to 2.88 kilogram meter squares and 709.3 kilogram times meter squares. And we would then add the center of gravity. We'd factor into the center of gravity by multiplying the mass of both objects times their distance of the perpendicular distance of said objects, which would be the radius of the sphere, because we are assuming that the center of gravity is the middle of that sphere. And we would come out to these values, and adding them together, we get a total mass moment of inertia of 713 kilograms times meter squares.